Good morning, students. Today we just start the unit definite integration. Okay, so what is that? Definite integration. Okay, in our previous unit indefinite integration we studied different types of functions, how we have to find the integration values, different types, different methods, okay, etc, etc. So we studied a lot in our previous unit indefinite integration. Now in this unit definite integration, okay, we have to study some properties and related problems in this unit. Okay, in this unit. So actually in the definite integration we just consider the function is like this. For the definite integration, integral from a to b f of x into dx, we just defined like this. That means a function, okay, integral values from a to b. In our previous unit we are not having the limits. This is called actually lower limit and this one is called upper limit. Okay, this is called lower limit and this is called upper limit. So it is read as integral from a to b f of x into dx, f of x into dx. So what is the difference between, okay, this one? That means we just study in simple manner. Already we know that integration of f of x into dx equal to, for example, g of x plus c, okay, or we can take that capital F of x plus c. So whatever it may be, suppose if we are taking like this, so here the process is integral from a to b f of x into dx equal to g of x plus c. Here we have to apply x equal to from a to b, so we have to take g of b plus c minus g of a plus c. Okay, so now we can take that g of b plus c minus g of a minus c plus c minus c get cancelled. Our final answer is g of b minus g of a. That means integral value of f of x into dx value is, for example, g of x. If you are having the integrals from a to b, so what is our value? Our final answer, we have to apply the from b to, that means a to b, so that final value is g of b minus g of c. Here we are not having the arbitrary constant. In indefinite integration compulsory we have to add the arbitrary constants, but in definite integration we are not adding the arbitrary constants, because finally we are getting the, okay, constant values only. This is the fundamental concept in the definite integrations. Okay, for example, I will take one thing, integration of sin x into dx, okay, from pi by 3 to pi by 6, pi by 3 to pi by 6 into sin x equal to, actually we know that integration of sin x into dx is minus cos x plus c. That means we are getting the one function plus c as the result. But here integration of sin x into dx means here also we are getting that minus cos x, but our values are, we have to take pi by 3, okay, pi by 6 to pi by 3. For example, pi by 6 to pi by 3, 30 to 60, pi by 6 to pi by 3. So minus cos pi by 3, upper limit value, minus cos pi by 6. So minus cos 60. What is the cos 60? Cos 60 value is 1 by 2. Minus of minus plus. Cos 30. What is the cos 30? Root 3 by 2. So our final answer is root 3 minus 1 by 2. So this is a constant value. We are getting a constant value. Example point of view here I am taking. So that means who are having the good idea on the integration, okay, this process is very simple thing. Okay, So here a to b equal to, what is that? We can take that g of b minus g of a. Okay, so this is our fundamental theorem where I am taking that integral f of x into dx equal to g of x plus c. Okay, so this is our concept. Okay, integral from a to b f of x dx equal to g of b minus g of a, where here integral value f of x into dx we can take it as g of x plus c. Suppose if you are having the interest, you just take capital F of x plus c, that thing also. In indefinite integration we are getting the compulsory capital C value, arbitrary constant we have to add. But in definite integration means from where to where we are taking the limits. Okay, where to where we are taking that function value. So finally we are getting the only constant values as results. Okay, in definite integrations we are getting the constant values as results. In the indefinite integration, for example, only integration of sin x value is minus cos x plus c. Okay, that means functions as results in the indefinite integration, but in the definite integration finally we are getting constant values or the results. Okay, so now we just discuss another simple problem. Okay, so here integration of x square minus x square minus x, this total into dx. Okay, integral values from 2 to 4. So here integration of x square into dx, x cube by 3. Integration of x into dx, x square by 2. For this value we have to take from 2 to 4. From 2 to 4. That means in the place of x, first we have to, okay, total upper value minus lower value. 4 cube minus 3 minus 4 square by 2 minus 2 cube by 3 minus 2 square by 2. So 4 cube 64 by 3 minus 16 by 2, that means 8 minus 2 cube 8 by 3 minus of minus plus 2 square by 2, 2 to get cancelled, 2 is the answer. So here if I take 3 is the LCM, 64 minus 8, 64 minus 8 means 56. Okay, 56 minus here minus 8 plus 2 means minus 6. So I can take that 3 is the LCM, 56 minus 18. So 16 minus 8, 4 minus 1, 3, 38 by 3. So our final answer is 38 by 3. Okay, so this is our solution, 38 by 3. Understand? So our final answer is 38 by 3. Suppose if it is indefinite integration, that means the limit values, upper limit, lower limit is not mentioned, then we can take that this is the only solution plus c. Okay, so if definite integration concept is given, that means limit values are given, lower limit to upper limit. Okay, then we can take, we have to find the same solution, upper limit for that result value we have to take the total upper function minus lower function value. Okay, so finally this is the right. So in this unit, like this we can do the many problems. Okay, so in this unit the main thing is the properties. Okay, so I am writing the properties. Property number 1. Property 1. We just discussed about the properties in the definite integration. Our first property is, for example, integral a to a f of x into dx. So this value is equal to 0. Okay, so here proof also I will give. You just observe that. So integral from a to a f of x into dx equal to, here I will take the, okay, g of x plus c, okay, from a to a. That means integration of f of x into dx value I am taking as g of x plus c. Okay, so from a to a, so g of a plus c, upper limit value minus g of a plus c, both will get cancelled, so I am getting 0 is the answer. That means in definite integration, if the upper limit and lower limit values are same, compulsory our result will becomes 0. Okay, so this is the main, that means not main, it is the first basic property in definite integrations. In definite integration, this is the basic property. Okay, right. Next, property number 2. Property number 2. Okay, you just observe that integration from a to b f of x into dx equal to, suppose if the integral values are reversed, b to a f of x dx, but here you are having the opposite sign. Here you are having the opposite sign. This is the, okay, we will do this problem by using one example. Okay, here I am taking that integral from 1 to 3 x into dx. Okay, suppose if I am taking this x square by, what is that, x square by 2. So for this value I am taking 1 to 3. So 3 square by 2 minus 1 square by 2. So here what I am getting, 9 by 2 minus 1 by 2, that means 9 minus 1, that means 8 by 2. Okay, so what is our final answer? 4. Suppose if I am changing the 3 to 1 x into dx. Okay, from 3 to 1 x into dx, we have to just check that. Here also I am getting x square by 2. This is the, okay, integration value. Here I have to take 3 to 1. So that means, okay, 1 square by 2 minus 3 square by 2. That means 1 by 2 minus 9 by 2. That means minus 8 by 2. So this value is minus 4. That means if we change the upper limit, lower limit, if we interchange that, okay, our final results will have the different signs. Okay, here we are getting the positive sign, here we are getting the negative sign. Okay, so if we interchanging the upper limit and the lower limit to the integral function, then, okay, our result will becomes the opposite sign. Okay, suppose if our previous result is some plus a, okay, if we interchange that, we will get the result minus a, like that. Okay, so here this is the property number 2, integral from a to b f of x into dx. So this value equal to minus of, okay, from b to a f of x dx. Okay, so this is the property 2. First we have to check the, we have to take some basic problems and we just apply the, okay, already we have the a good idea on the integration value. For that you just apply the upper limit value minus lower limit value, we will get the some basic problems in definite integration. Okay, we just first practice that type of problems first. Okay, right. So in this class we just studied the basic 2 properties. Okay, right, just refer this. Thank you.